I got the answer as 1170 Kelvin. Dapat tak? Okay, anyone?
Doctor, your answer is 1117 kah?
1170.
1170. Oh, different.
Okay, never mind. Let me just explain. Tapi nanti you check balik because I'm also not sure if my iteration tu betul ke tak. This is not really iteration actually. It's more like a trial and error lah for this part. Okay. Okay. Okay, so you have the equation for HCl. I will show you the step by step dulu. Later you can calculate again. Okay. For HCl in gas plus into H2O is okay, so you have 4 HCl gas plus O2 gas to get 2 H2O gas plus 2 Cl2 gas. Okay, and then you are given in the equation in the question equimolar of HCl and air. Yeah, so in this case I use my basis as 4 moles of HCl. Okay, so if you use 4 moles, so you can calculate your inlet ataupun your reactant, inlet or your reactant stream. You will have HCl, which is 4 mole, and then air. Okay, so air is composed of oxygen and nitrogen. Okay, so oxygen is 21%, so 4 times 0.21, which is 0.84. And then the nitrogen is 4 times 0.79 equals 3.16. Okay. Right. This is in the inlet ataupun reactant stream. Okay. So next you have to consider the reaction. Yeah. Berapa banyak yang reacted. So in this case reacted ialah dalam soalan dia kata 75%. Yeah. So 75% out of 4 moles, okay, you kena calculate lah 4 darab 75%, which means 3 moles. Yeah. So reacted HCl 4 darab 0.75, which is 3 mole. Okay. And then for oxygen, so for oxygen based on the stoichiometry, okay, kalau you tengok dekat stoichiometric punya ni kan, this balance equation, if you have 4 HCl, then this will be 1 mole. Okay, 4 moles, ini 1 mole. Kalau dia 3 mol which is 75%, so this is also dia akan jadi 0.75 lah. Okay, because 1 times 0.75. So oxygen yang reacted is 0.75. Okay. So maksudnya dekat sini dia ada excess lah. Okay, so HCl you have 1 mole excess. And for oxygen you have 0.84 minus 84 minus 0.75 which is 0.09 mole excess ya. Yang lebih. So yang lebih ni dia akan masuk ke dalam product stream. Okay, so your product stream will be those yang unreacted and also those that were produced from the reaction. Okay, so you have HCl. Okay, you ada HCl which is 1 mole, and then oxygen yang balance not reacted to 0.09, and then you have the nitrogen because nitrogen is from the air and it doesn't take part in the reaction. So samalah 3.16 mole. And then you have H2O from the reaction. This one is produced from the reaction, which is 2 times 0.75. Yeah, so that means 1.5 mole. And also Cl2 1.5 mole. Okay, sampai sini ada soalan tak? Up to this point, can you all understand how we do the calculation? Okay, first you need to make sure your mole number is correct, yeah. So you have to know what is the mole for the reactant ataupun inlet, and then how many reacted, and then from there your product stream. Okay, the mole number of the product stream. Kena list outkan semua dulu. Okay, alright. So next. Okay, so next you can consider your calculational path, yeah. It's always convenient to draw your calculation path. So your inlet is 550 degrees C. Okay. So you have your inlet, you punya product, your punya reactant is at 550. Okay, this is your inlet. Okay, and then you have to reduce to 25 to the standard temperature, and then this is where the reaction occur, and then you get your product. Okay, and then the product will be heated to the maximum temperature, which is unknown here, T. And this is the total heat transfer ataupun total enthalpy lah, delta H. Okay, so here is the delta H R, kita letak R because it's reactant, and then this is the standard heat of reaction at, salah. So this is the standard heat of reaction at the reference temperature 298 ataupun 25 degrees C, and this is the heat of the product. Okay. So in this case, the total heat transfer ataupun total enthalpy dia ialah all the total of this lah, summation. Okay. Right. So kita kira yang it's up to you lah, you nak kira HR dulu ataupun the standard heat of reaction. Okay. Because this is easier, we calculate the delta H not 298. So this one you can get from the standard heat of formation data, yeah. So you can refer balik to, you have to refer back to your equation here. So you have HCl, okay, and then O2 is an element, okay. So kalau dia element dia tak ada heat of formation lah, okay. And then you have H2O as the product and Cl2. So again, Cl2 is an element. So you just need the data for H2O and HCl. Okay, and then for product, the stoichiometric number will be positive. For reactant, the stoichiometric number will be negative. Okay, so your heat of reaction will be, in this case, 2 sebab dia ada 2 mole of water. This is the standard heat of formation for water. And be careful sebab water dia ada dalam gas dan juga dalam liquid. So in this case it's in gas, so you have to use the value for gas, okay, sebab dia ada gas dan liquid, so you have to be careful. And then minus 4 times standard heat of formation of HCl. Okay, yang ini. Okay, so you dapatkan value of standard heat of formation for H2O and HCl from the appendix. You akan dapat this one, negative 114408 joule. Okay. Okay, so this is for this value tadi, negative 114408 is for this reaction. Kalau ada 4 mole HCl plus 1 mole oxygen, okay. But now you have only 3 mole ataupun 75%. So to this figure, you kena darab 75% lah, okay. So this value ni tadi, you kena darab 75% because actual cuma 75% sahaja yang react, okay. So this actually you have to times 0.75, okay. Which is negative 85,806 joule. Okay, so that is the standard heat of reaction. Okay, next you calculate the delta HR. Okay, untuk calculate delta HR, this is this is sensible heat. Okay, so you need the data for ABCD, heat capacity data. Okay, so normally I prefer to arrange my data in a table form macam ni. So ini ialah inlet ataupun the reactant, reactant. So you have the HCl, and then you have the oxygen and nitrogen. Okay, and then this is the mole. Mole tadi apa? For HCl you have 4 moles, and then oxygen is 0.84, and then nitrogen is 3.16, and then you can list out lah dia punya A, and then B, C, and then D. Okay, so A, B, C, D you have to take from the appendix C. So this is 3.156, 0.623, ini tak ada, 0.151, this is 3.639, 0.66, this is negative 0.7, and then this is 3.280, 0.5, 93, 93, and then this is 0.00. Okay, so lepas tu you kena dapatkan, sorry it's a bit dirty. Let me just, lepas tu you kena dapatkan the total ABCD. Okay, so this is the delta ABCD. Sekejap mana tadi value. Sekejap, saya tak jumpa mana tadi. Okay, sekejap. Alright, so you calculate the delta A, delta B, delta C, delta D. C tak ada lah. Okay, so just delta A, B, C, A, B, D. So delta A, 26.0456. Yang ini 4.7909. And then this is 0.5397. Okay, so dah dapat ni, you can calculate delta CPH over R. So you need to calculate tau first. So your tau is 550 times plus 273.15 divide with 298.15. So your tau is 2.7609. Okay, and then for CPH over R, this is the CP over R. Okay, so you just have to substitute the value of delta A, delta B, delta D, and then the T0 is the reference temperature, 298.15, and then the tau. Okay, so substitute, akan dapat 28.952. And from there, your delta HR is CP H times T minus T0. Okay, so 8.314 times 28.952 times 25. Okay, dekat sini you have to be careful ya, sebab it has to be final temperature minus initial temperature. Okay, so final temperature dia ialah 25 degrees Celsius and the initial is 550. Okay, kalau you terbalik, you akan dapat simbol dia terbalik. Okay, and your final answer will be wrong. So you have to be careful there. So this is negative 126.369 joule. Okay? Up to this point ada soalan tak? Siapa yang tak faham sampai sini? Boleh sampai sini? Alright, so next you have to find the HP, delta HP pula for the product stream. But the problem here is that we don't know the final temperature kan, sebab kita punya T tu kita tak tahu, yang tu kita nak cari. So it's a bit complicated sikit lah. Yeah, it's a bit tricky. But still you have to do the same step. Okay, you need to list out the mole number of the product stream. So sama juga macam yang ni tadi kan. Kita buat juga table macam ni. Okay, you list out the product and then the mole number and then the ABCD. Okay. Oh, sorry. So, just enter. Okay. Sekejap Maybe saya ambil foto lebih cepat kot daripada tulis. Sekejap. Let me check. Okay. So basically it is the same. It's the same process as just now. Sekejap Okay, so for the product, we have the mole, and then the A, C, and E, C, right? And then you have HCl, O2, nitrogen, H2O, and Cl2. Okay. 0.09, 3.16, 1.5, 1. Okay. Oh, yang ni saya tak tulis balik lah. Okay, you can find by yourself. Saya cuma tunjuk total yang bawah ni, delta dia. So delta A is 25.716, delta B is 4.851, C tak ada. This is negative 0.0775. Okay, so here you have to assume you punya T, any T. You can start with any T that is higher than 550 degrees Celsius lah. Okay, so let's say we start with 1000, 1000 Kelvin. So you can calculate your tau. Okay, so 1000 over the reference temperature 298.15. So 3.354. So then you can calculate Cp, H over R. This is 28.839. Lepas tu dapat delta HP. This is 1682. Yeah, I think you can put it in kilojoule. It's better, I think, kilojoule. So 168 point, sorry, 168.28. 168.28. And then this is the delta H. So delta H tadi ialah total semua And this must be 0 untuk you dapatkan maximum possible temperature tadi. Okay. So in this case you get delta H as negative 43 point. This is kilojoule, kilojoule 894. Okay, so we try another value. Let's say 1500. So kita repeat lagi. Kira tau. And then CPH over R. So, and then this is 300 point 368, 3637. And then this is 88.193. Okay, so from these two value, okay, you can see that when we have the temperature as 1000 Kelvin, you get the total is negative 43 or negative 44, yeah. And then when it's 1500, you get it's 88. So from here, to get the total 0, the value of T must be somewhere in between lah, kan? Sebab, you know, it must be in between 1000 and 1500. Okay, sebab kat sini you dapat negatif, kat sini you dapat positif. And kita nak dapatkan dia close to 0. Okay, so you try. Finally, saya dapatlah roughly 1170. 1170 dapat 3.924. This is 29.255. This is 212.0567. And then delta H is about not exactly 0, dapat almost lah 0.118, which is acceptable lah. Okay, and if you try to increase by 1 Kelvin, kalau you try 1171 ataupun 1169, you still cannot get, I think this is the lowest you can go. Okay, unless if you decide to, you know, also get the 0 point something, mungkin you boleh dapat lah. tepat-tepat 0. Okay, but in this case, this will be acceptable. 1170 Kelvin. Okay, which is here is around 0. Okay, so in this case, the answer is 1170. Okay, dapat tak semua orang? Okay, do you understand the step? Okay, basically, why are you sad? Yeah, the if you if you go through the question, soalan dia pendek tapi penyelesaian dia is quite long, right? But in the exam, because you have, in the test, if you have because we have limited time, so most probably the question will not be this, the solution will not be this long lah. Okay, sebab kalau you nak solve just this one question, probably will take 1 hour, just for one question. So in the actual test, the question itself will be much simpler lah. Mungkin you akan ada cuma HR sahaja, okay, and then the HP will be 0, for example. So normally just one calculation of this, that is requiring this table, so that you don't spend too much time for the calculation lah. Okay, so saya ulang balik So for this type of question, first, okay, you need to know what is your reaction, and then from your reaction, you get all the information, apa yang diberi dalam soalan, berapa persen reacted, and then berapa mole yang ada, all those information. You need to calculate the mole number, okay? So you need to know the mole number of the inlet ataupun the reactant, and then how much reacted, and then also the outlet ataupun product stream. Okay, and then from there, you can calculate the heat of reaction. So in this case, the heat of reaction here, you have to times 75, 0.75, because it only 75%. So this heat of reaction must be according to the actual reaction that took place. Okay, mesti berdasarkan mole number yang terlibat. Okay, the actual reaction. And then you can calculate for the reactant stream and also the product stream. Okay, and then in this case, kita kena buat trial and error lah, sebab kita tak tahu final temperature. So you have to guess the value of T. Okay, to get finally the total of H will be approximately 0. Alright. Okay, so for this calculation, you have to be careful in terms of the temperature difference. It must be final minus initial, yeah. So dekat situ kadang-kadang bila you tersilap, dia akan affect all your calculation. Alright, ada soalan? Okay, so later I will put your assignment 1 in the e-learning. Next week, we have next week, this week is week 5, next week is week 6, and then after that you have the mid-sem break, kan? So kita plan nak buat test 1 on the week, 1 week after the semester break. So that means, tadi saya dah tanya section 1. Tentatively, the test 1 will be done on 11 of May, Wednesday, malam. 11 May, Wednesday, 8 PM. Test 1. Okay, tentatively lah. Kalau semua orang okay, I'm also asking section 1, if everyone is okay, then we will proceed with this date, yeah. So test 1 will cover chapter 3 and chapter 4, and the time is normally 1 hour and 30 minutes. So later in the e-learning, I will also share with you the questions, past year's questions from the test, yeah. And also your assignment, Saya nak beri masa berapa lama 1 week. Okay, so I will give you 1 week for your assignment. Boleh Assignment tu nanti saya akan, I will put in the e-learning, so you also submit through e-learning. So that means I will give you 1 week, so the due date will be next week, Thursday lah, 28, just before your mid-sem break. Okay? Right, any question? Ada soalan? Tak ada? If no question, we will stop here.